the exam. We'll work through quizzes starting with chapter 1. If you've already got them done, that's great. But it'll also be kind of a review of the topics that are going to be on the exam. And once we get through the quizzes, I think, when did we start working them as a class? Was it chapter 5 or chapter 4? Does anyone remember? I was thinking it was about 4. But so we'll at least get the 3 done, and I'll see if anyone wants to look at 4 or 5. We could do that too. It shouldn't take us too long for those. And then the main thing to do is focusing on here under the midterm is the midterm exam review. Again, it says it's worth 50 points, but I actually don't have it as part of the grade. So that you can go in and you can review what you need to review. The parts you already know, you're not forced into it. But just to let you know, what I've done is I took the midterm review, I deleted about half the questions, and that's what the exam is. So the exam comes from it, so it gives you a feeling of what's on the exam, how the exam works, and actually everything works the same, except I believe in the review I turned on some of the resources like videos and stuff. The test, those aren't there. When you do take the test, you get to use your notes. So anything you got your notebook, whatever, as you work through things, whatever, you're welcome to use them. You don't have to. Sometimes it helps if you narrow it down to a couple pages. That's up to you, though. You can use any of your notes. Goal is to take the test here in class, so you'll have the option to take it either Tuesday or Thursday, whichever works best for you. If you come and take it Tuesday, you don't have to come to Thursday. If you're planning to take it Thursday, you don't have to come to Tuesday. And since probably people will be taking the test, it'll be hard to, I maybe quietly can work with somebody. It is password protected, but once you get here, I give you the password so that you can open it up in class. There's no proctoring software on it, no videos or anything like that, but it's in the More system. You'll see it, you'll take it right through Canvas, so it's just like you're doing homework. You'll have the full class time to work on it, and again, you get your notes and such. Those who are not, for whatever reason, able to make it during next week, we can make up midterms by using a proctoring service. We'll work that out, see who needs that. Okay, so goal is to get you all through, and then next week was planned to do kind of a project. I've taken that project out anyway. We'll be fine without it. So we don't really lose anything. Then we'll pick up with chapter 7, 8, 9, and we'll do that. And the final is just the second half of the class. So it's kind of like 2 halves of the class. And we'll start in there and be doing just fine. So now we've gone through all that. Let's go to chapter 1 quiz. So I don't know, it's about 5 or 6 questions. I don't even remember what chapter 1 was about, but we'll figure it out when we get there, right? So let's go for, let's reset it and just start it. Let's see. Oh, I've already taken it, so it's only going to give me, oh, that's good. You'll earn a maximum 70%. So I think I took these penalties out. I'll double check it, but if you take the quiz a second time, you don't, I don't plan on, I think I took all those out, but I'll make sure that those are gone. Okay, yeah, so this one was on units, right? Kind of conversions for chapter 1. So find the unit rates, if necessary, round your answers to the nearest hundredth. And so this one is dollars per kilogram. So let's see, where's my pen here? And again, you'll probably have different numbers. That's how it works. Let's go here. Welcome. Let's go with blue today. So dollars per kilogram, that means dollars are in the numerator, kilograms in the denominator. So that would be $6.59 divided by 4 kilograms. And then we do the math of 6.59 divided by 4. See, all we need is a little, where's my calculator? I think it's back here. Just a simple calculator will do. So 6.59 divided by 4. So that unit rate is $1.64 per kilogram, right? So that's what we put into here. Actually rounded up, $1.65. 1.65. But if you wanted kilograms per dollar, because all you got is $1, so you want to see how many kilograms can you buy, you need to do the division the other way around. So for this unit rate, we do 4 kilograms per $6.59. And when you do that, you'll see you get actually for $1, you're not even going to be able to get 1 kilogram, but 1 kilogram is about 2.2 pounds, so you still may be fine. So that'll be 0.61 because we want to round it to the nearest hundredth. Okay, 0.61. And again, it doesn't check you as you go, does it, on these quizzes? Or, oops, not 1 point, it's 0.61. Check your answer. Oh, it does. Okay, good. Any questions so far? You okay? Good. Let's go to the next one. Oops. Yeah.
Up there.
Oh, up.
That happens to me too.
Shoot.
All the questions are still answered.
Okay. Sometimes, yeah, these things happen. That's the electronic stuff in the ASU one. If you swipe to the side, it goes away, and then it's really hard to get it back. And I've had students.
Press the back arrow at the top. I think you should be fine.
Thank you. Okay, so that's why I got experts here that know how to navigate. Okay, thank you. And then when I could just resume. Okay. First question. Okay, so we've already got the. Oh, thank you. I'd like go up here, and this is the better way to go. Okay, so don't go to next. Let me, actually I should make this a little bit bigger. I guess it's not too bad. But, so this is a factor labeling method. So you kind of work out your stuff here. So if 1 meter equals 100 centimeters, that's going to be our conversion here. So we've got 527 centimeters. We want to know how many meters that is. So since we kind of want to get rid of centimeters, that's always, we divide those out. So centimeters go in the bottom. In our equality up here, we've got 1 meter equals 100 centimeters. So the 100 goes here. And in the numerator, 1 meter goes up here. So this is our factor of 1 because these two are the same. We're really just multiplying by 1. And so the math is just 527 divided by 100. We can do that by moving the decimal over 2 places. So that's going to be 500 or 5.27. And what is left? Well, the centimeters canceled out. In fact, actually, I can do this with my writing. Let's do it in red. Centimeters cancel. We did the division, and so what's going to be left are meters. And so we put that in there. And that's what I like about using the metric system is usually you don't have to do as much calculation. It usually just involves moving the decimal place. It's a lot easier to do the calculations. Let's delete those. That's okay. Okay with that one? Mm-hmm. Okay. We'll just go through another factor labeling one. So again, 2 of these, you could probably see there's probably going to be one on the exam. So we got gallons. How far can you drive on 60 gallons around your answer? your car can drive 480 miles on a tank of 23 gallons. So it's kind of like those things, that's your, you go either 480 miles or use up 23 gallons. So again, we want to get rid of gallons. We want to move it to miles. So gallons goes in the denominator. We've got 23 there. So then that must mean miles goes in the numerator, and that's 480. So that's the ratio we're going to use. One tank of gas gets us 480 miles. So again, the gallons will cancel. We'll take 60 times 480 and then divide by 23. I think I'm going to need a calculator for that. So we'll pull this one up. $60 times 480 equals that, and then we divide it by 23. Tells us we should be able to go 1,252 miles. But you think of it, doesn't that kind of make sense? 60 gallons, that's about 4 times 23 roughly. So you could take about 4 times that. Oops, forgot what it was. 1252 round to the nearest mile. So just 1252 we'll do here. And again, you'll probably have slightly different numbers, but the method should be the same. And then if you have to go so many miles, you want to know how many gallons you need. So again, the miles is what we want to get rid of. So those go in the denominator. And we have our ratio is 480 miles, gives us 23 gallons. And we'll divide and multiply, or multiply and divide. Again, you could do it in either order. So let's go with 920 divided by 480. So you can see it's almost two tanks full of gas. So you multiply that by 23. So you'll need 44 gallons. 44 gallons will get it done. And I think it was 0.08, so actually going to be 0.1, nearest tenth, 44.1. And those are gallons of gas. Check our answer. Still doing good. So we got 3 out of, how many were there? 6? Yeah. Okay. So this is one that's kind of nice. If you travel, this is a lot of times what you're doing is you're converting currency units to figure out what you're paying, but you're also converting, if you're buying gas, your gallons to liters as well. We don't have a setup for us, but we'll go ahead and go with this. So in September 2016, the cost of gasoline in Berlin was around 1.2 euros per liter. What was the equivalent cost in US dollars? So on that day, what we do is we start off, we've got 1.2 euros. That's kind of like that funky E is what they use for their currency, something like this, I think. Or you could just put euros, it doesn't matter. Euros per liter. I'll do a scripted L for liters. So our conversion, we want to get rid of liters and euros. So we have 2 conversion factors here. Which one do you want to start with? Do you want to start with the money, or do you want to start with the units, the liquid? The units? Okay, so let's, we want to get rid of liters, and think of this as going to be 1 liter. So we put the liters in the numerator, so that's 3.785 liters. So those are going to cancel, and in the denominator goes 1 gallon. Okay, and I kind of like to, as I'm going, I say, okay, this liter is going to cancel with this liter, but we kind of see what we're multiplying. So then the next unit, and we can do this all on one line. You could, if you wanted to, you could calculate it and then have a new number and work forward, but you can also do it with just all the conversion factors on one line. The next thing is we've got to convert the money, And we want to get rid of the euros. We want to change it to dollars. So the euros has to go in the denominator. And again, I'll just use that funky E, 0.876. That's what goes in the denominator. In the numerator is going to go $1 US. And again, I like to, just as I'm going, so this euro is going to cancel with that euro. So in the end, I've got all these numbers. I've got 1.2 in the numerator times 3.785 times $1. Again, that's not a big deal. And then I've got 1 times 1, and again, my units in the denominator are going to be gallons. I guess in the units in the numerator are going to be dollars. So that's good. And so we get 1 times 1, right? This 1, and times 0.875. So really, I just need to take 1.2 times 3.785 and then divide it by 0.875. So it helps us line up what the calculations are. And whenever we're converting, we're either multiplying or dividing, but this unit analysis helps us know whether we're multiplying or dividing. So 1.2 times 3.785. I'll go ahead and put equals. And then we're going to divide by 0.875. Or, yeah, 0.875. So at that time, their gas was $5.19 a gallon. I guess we could just put that here. What was it? $5.19, yeah, rounded. Which back in 2016 seems extraordinary, but we kind of gotten used to it. That's about what it costs here now. Wonder what Europe's costing. Oops, what did I do wrong? It didn't like it for some reason. Did anyone see anything I did wrong? 1.2 euros.
0.76 and 0.75.
Yeah, I make up my own numbers. Thank you. Okay. So let's, good. See, I don't spot it because so it was a 6 here. There was a copy error. It should still be a 6. You can't just make a 5 into a 6 because you want to. So we're close, but not close enough. Let's do that calculation again. 1.2 times 3.785 equals that, divided by 0.876. There we go. So it's $5.18 even rounded. So we were off by 1 penny, but off is off, right? So we'll change that to 8, and hopefully it'll like it now. There we go. So we'll clear out the work, and that's of the conversion parts. That's usually one of the more difficult ones because it's got 2 conversions in one. And I don't know, I find it better to go just do it all on one line. If you want to do it one at a time, you can do that as well. All right. Long year-end status report for work is 131 pages long. You need to print 18 copies. So we kind of highlight what we need to do. For a meeting next week, how much is the paper going to cost you for those reports? Paper sold in reams of 500 packages for $3.61 each. Give your answer to the nearest cent, only for the paper you use. So partial reams are okay. Not usually. I don't know many stores that let you say, oh, I only need a few pages, so let me they charge you for the whole ream. But okay, we'll go with it. So how much paper are we going to need? The report's 131 pages, And we need 18 copies, so this will tell us how many pages we need, right? But we're not paying by the page, we're paying by the ream. So what we're going to do is we're going to take this is total number of pages, we're going to divide it by 500, and that will tell us how many reams we have to buy, or partial reams. Pages per ream. And then what we're going to do is multiply by the cost for each of those reams, right? Because this will give us the number of reams. Then to get the cost, we simply multiply by 3.61. So I'm actually going to do this in 2 steps. I'll figure this out because that'll tell me how many reams we need. Something that would be nice to know. 131 times 18, that's how many pages are going to get printed. But if you've got printers or copiers like I'm aware of, you usually need some extra pages anyway, right? Because they get jammed and you lose some. Divided by 500. So we're going to need 4.7 reams of paper. And again, you go to the store, they're not going to sell that to you. You got to buy 5 of them, but 4.716. And then, so we're going to multiply that by the cost. And use as many decimal places as they give you, and then just round the answer at the end to the nearest cent. So that means 2 decimal places. So then we take that number times 3.61, $3.61. So it'll cost us $17.02. And if I wrote down all my numbers correctly, it should be correct. And again, that's just for the paper. You know, I'm assuming, and that worked. Okay. Again, you could have also set it up more in a unit analysis ways, but I think some of these are good to go through with problem solving. So let's go through 6. Bicycles traveling at 20 miles per hour. How many feet will it cover in 25 seconds? I think I remember a few asking about this particular question. 25 seconds, okay. So there we go. So 20 miles per hour, 20 miles. And it wants our units to be in feet. It didn't really say that directly, but so we've got 20 miles per 1 hour is our rate. We want it, we've got to convert the hours to seconds, right? Because that's all we're doing. And then we also have to convert the miles to feet. They don't give us any units here, so we would have to look them up, which, again, if it's on an exam, you could use Google to do it. But hopefully this is one that is helpful, that 1 mile contains, I think it's 5,280 feet. Is anyone able to verify that? Is that about right? Because I'm pretty sure, like 99%, but I also know that.
Yeah, you were right.
Okay, I thought so. Sometimes I transpose. I've occasionally said it's 5,820, so I transpose them. So, you know. So that's going to be one conversion again. So we could do that as a first conversion here. We put the miles in the denominator because we want to get rid of the miles, and then 5,280 feet go up here. Okay, so we've done sort of the first conversion. We've got it over to feet. Now we just need to get rid of the hours. So in 1 hour, how many seconds are there? I don't know, but there's 60 minutes in an hour. Okay, so we go from hours to minutes, and then in 1 minute, there are 60 seconds. So we could have taken 60 times 60 and gone directly from hours to seconds, but this will do it. And again, we just multiply straight across. So we'll do 20 times 5,280, and I'll gives us 105,600. And I guess like I said, I should come here and say, okay, we got rid of miles, we got rid of the hours, and then we got rid of the minutes. So the units that will be, so when we're done, we know we're done. This is going to be in feet per second. And, well, we're not quite there yet, but we'll get to the end. So in the denominator, we've got 60 times 60. 6 times 6 is 36. There's 2 zeros, so we put those on the end, so it's 3,600. And again, our units are now seconds. And this is feet. So what we've actually done so far, though, that would just convert the 25 miles per hour into feet per second, right? What do we want to know? We want to know how far we've gotten in 25 seconds. So the last step would also be to multiply by 25 seconds so that our final units are just feet, not feet per second. And again, I can see, okay, yeah, seconds are going to fit. So we can do this either way. I'm going to go with this number divided by 3,600 down to 109. Wait, that wasn't right. Oh, it divides up there. I added. Okay, so it's 105,600 divided by 3,600. Gets us about 29 feet per second. So then if we multiply that times 25, it will tell us how far so 733.3 feet, because they wanted to the nearest tenth. So 733.3. Let's check the answer, and we got it right. Okay, so that's a sort of a multi-step conversion. Gets us there. All right, how we doing? Is that helpful? So there's a section on, and I think the exam, if I remember right, is maybe 25 questions. So if you divide that by 6 chapters, roughly about 4 questions per chapter. And I try to distribute it fairly equally. Okay, so that one's done. I will leave it now. Of course, you need to submit that at the end, right? But, okay, shall we keep going? Okay. So chapter 2 quiz. And notice that I moved everything, the quizzes and the homeworks, to next Friday. Let's see. How many? Just 6 questions. I think most of them are 6 questions, right? So this was linear equations, y equals mx plus b, or solving. So we'll maybe move a little bit. We'll move along as we need to. So we've got an equation where this one we just need to solve for the variable. So remember, we do the same thing to both sides. So t minus 11 over 10. We're dividing by 10, so we multiply both sides by 10. So 10 divided by 10 is 1. That gives us t minus 11. 6 times 10 is 60. And then to finish solving this, we add 11. So remember, we're always doing the opposite when we go to solve. So t is 71. And again, your number's probably different, but same sort of process. We got that. Oh, and I can just click here. Let's get rid of that stuff. Oh, this long one. So before I start reading all this stuff, let's highlight a few things. So we've got an equation here. Gives the recommended maximum heart rate, m, in beats per minute for a person who is 80 years of age. Determine the age of a person whose target heart rate is 156 beats per minute. Gives the recommended maximum heart rate. The maximum heart rate is the highest rate that will achieve during maximal exercise. In general, you get the most benefits and reduce the risk when you exercise within your target heart rate zone. Usually this is when your exercise rate pulse is about 80% of your maximum heart rate. Okay, so we get this formula here. In beats per minute for a person who's 80. So the target, okay, so this target heart rate, where does that go in this equation?
Where did I have 220?
Well, the A is for age.
Oh.
So that's what we're trying to find out. The M is actually, I don't know why they didn't put T for target heart rate, but M is the target heart rate, right? So they're telling us our target heart rate is 186. So we're taking this equation where the M is, we're putting our 156, sorry. And then we've got 0.8 to 20 minus A. So now we're going to solve for A, and that'll give us our age, how old that person is. Again, sometimes we think, oh, I got to distribute through, but when we have these kind of problems, it's actually easier if we just, because we want to, what the goal is to get A by itself, so we could divide by 0.8. Since we're multiplying by 0.8, divide both sides by 0.8, and we will get there a little bit faster. So 156 divided by 0.8 gives us 195. So we've got 195 equals 0.8. Oh, no, we got rid of the 0.8, didn't we? Oh. Go here. They canceled out. So we get 220 minus A. Notice how it's much nicer. What would we do next? Trying to get A by itself. Maybe subtract that 220. So 95 minus 220 is going to be negative 25 equals negative A. And to get rid of a negative A, I was thinking of it as a -1, we could divide by -1 or multiply by -1. Both of them get the negative gone. I like to just think, let's multiply both sides by -1. So we get 25 years old is the age, because it doesn't make sense to be a negative age, right? So this is a heart rate for a 25-year-old. And that's good. Does that make sense? Again, with equations, we're either given the input or the output. In this case, we're given the output. We have to actually go through and solve. Okay. 3. Find the slope of this line. Do you remember how to find slope? It's rate of change, right? So there is a formula for that. Also, remember, I don't really use the formula. What I do is I take one point and put the other point below it. So this is your x, that's your y, and what I do is we're just going to subtract the second point. And you could do it in any order, but I just think it's going to be easier. So I take 7, subtract -2. So if you subtract -2, that turns it to a positive. So 7 plus 2 is 9. Then we do 3, and this negative comes over. 3 minus 2 gives us 1. Positive 1. And then at the end, slope is always y divided by x, so we take this and tuck it underneath. Our answer is going to be 1/9. Now let me do it in the more sort of the way that books all teach it. They teach you that slope is what you call m, y equals mx plus b, right? They say use this formula, y2 minus y1 over x2 minus x1. So what is y2? It's one of the y values. Let's go with 3. Subtract y1, which is 2. Notice that's what we did here. We're going to get 1. And then x2 is the 7. x1 is the -2, so 7 minus -2. And notice that's what we did here. But it's just different ways of lining them up. My way, you don't have to use a formula. And it's not really my way, it comes from ancient India, but that's the way they taught how to do it. So 3 minus 2 is 1. 7 minus -2, which becomes a plus, is 9. So we get 1/9 either way. Questions on that one? It works. Because when I use the formula, sometimes I get them mixed up. I put things in the, and it's less problems if I just line them up. And then it's also easier, it's more visual. So 3 more problems. So on this one, on these, let me, we're going to, just by looking at this equation, we're going to be able to come up with the rate of change and the initial value. So the rate of change here, it's the number in front of the x. Whenever you have y equals mx plus b, the rate of change is the number in front of the x, 10. The initial value, well, that's the y-intercept, that's the number that's by itself. If I plug in 0 for x, 0 times 10 is 0, y equals -8. Our initial value is -8. And then the behavior, since the rate of change is positive, it's going to be increasing. And we'll be able to see, I think I need to make it a little bit, there we go. The answers are it's either increasing, horizontal, vertical, or decreasing. But it's increasing because it's got a positive slope. How about the second one? What's our rate of change? What kind of 6? Positive or negative? -6, good. So the negative does go along with it. And since the rate is -6, what do we know about the behavior? Increasing, it's decreasing, good. I'll go ahead and do that. And then what's our initial value? 4, number by itself, and that's a positive 4, so we can just put a 4, we're good. Second one, our third one, y equals 2a, so I guess it's not always x, but the variable, our rate of change 2. What does that mean about our initial value though? Is it undefined? It's 0, good. So this could also be +0, so when it's 0, it doesn't show up, good. And so what kind of a function is this? It's increasing because it's positive. And here we have a y equals -9. There is no x variable. So what does that mean about our rate of change? What's that?
Decreasing.
Well, it's a horizontal line.
There's no slope.
There is slope, but what kind of a slope? You think vertical lines are undefined slope. So 0. So it's really y equals 0x minus 9 if you want. So that's the other one, is when you don't see the x variable, or what's supposed to be the x variable, it's because the rate of change is actually 0. So those sometimes are harder to deal with because it's like it's missing stuff. And this is a horizontal line. Vertical lines are going to be x equals a number. So that's how, and those are even harder to deal with because you just have to know x equals a number. That's a vertical line. Slope is undefined. There is no initial value because anyway, it's all messed up. That's why they didn't do it here. So we'll check our answers and hopefully we're right. We are. Okay. Let's see, what else did we get with 5? So here we're given an equation. It's the balance in your college payment account after Q quarters. So it looks like you got that. Interpret the slope of the situation. Balance of this account, is it increasing, decreasing, or staying the same? Decreasing, right? So because you're paying out that's your tuition that you're paying out, so it's going to decrease each semester. And what's the rate? The rate of the decrease is 1,900. And those are dollars. Well, not just dollars, they're dollars per quarter, right? Because a rate always has two parts to it, dollars per quarter. So that's what your tuition must be. Interpret the initial value of the situation. So our initial value is the number that's by itself. So what does this 15,200 means? $15,200. That means that's what we had when? Before we started paying. That's our initial value. So after 0 quarters, we had 15,200. How many quarters will this account pay for? Now we actually have to do some math, right? So we want to figure out when is the account 0, because then that means you can't pay anymore, right? So the maximum number, we can set it equal to 0. When does this balance run out? And usually we could subtract the 1,500, but since this part's negative, let's just go ahead and add 1,900 Q to both sides. So we're going to get 1,900 Q equals 15,200. So then we're going to divide by 1,900. And you might have figured that, well, yeah, if it's going to cost that much per quarter, all we got to do is divide the cost per quarter into what we have. And since we're not getting any interest on it, at least they didn't say anything about that, that would tell us how many quarters we can last. 15,200 divided by 1,900 tells us we can go for 8 quarters. Then our money's gone. Quarters, huh? Someone who ever wrote oh, that's right. Most of this guy was written by a guy up in Walla Walla in the Northwest. We're mostly on quarter systems. So three quarters a year rather than 2 semesters. And we're all good there. Okay. Do this last one. In 1990, the cost of tuition at a large Midwestern university was $96 per credit hour. 2000, tuition had risen to, wow, $176 per credit hour. Determine the linear equation C to represent the cost of tuition in terms of X, the number of years since 1990. So 1990, what we've got is a cost of 96 So what we can do is actually set it up as a time series. So what they want us to do is years since 1990, so we want to think of 1990 as year 0. So we've got 1.096, that's what it costs then per credit hour. And then the year 2000, which is how many years later? 1990 minus 2000, that'll be 10 years later. It was 1,706. And that'll allow us to come up with the equation. We can get the slope this way, right? And again, we can set up the formula y1 minus y2, or we can just do it vertically. Actually, it'll probably be easier if we put the smaller numbers underneath. So let's do it this way. So 10 minus 0 is still 10. 176 minus 96, that's going to be 80. Is that right? Yeah, I think 80. And then again, what we do is we take the x, we tuck it underneath the y. So it went up $80 in 10 years. So that means it went up $8 per year on average. 80 divided by 10. So we're starting to get an equation here. That would be C equals 8 times X is the number of years. And then we need a y-intercept. We need a starting value. Do we have that? Yes, indeed. In year 0, it was $96. So this way we can figure out if that did happen, if it was actually $8 per year, then we could calculate for any year. So C equals 8x plus 96. In the year 2007, tuition will be what? Well, okay, 2007 is how many years after 1990? Quite sure, we're really just subtracting, right? 1990, so that's going to be 17 years. And so to figure out that cost, we just plug it into our formula now. 8 times 17 plus 96. 8 times 17 plus 96. Let me, sometimes there's stuff left over. Let's try that again. 8 times 17, okay, plus 96. 232. $32 per credit hour, and then in the year blank, tuition will be $312 per credit hour. So for that one, we just take our equation and we put in the 312 for the cost, and then we solve for what year. So let's go ahead and do that. 312 equals 8x plus 96. Subtract 96 from both sides. That gives us 8x equals 312 minus 96. Anyone got a calculator handy? I can get to it faster than me. Let's see, 312. $216. And then the last step was, oh well, at least this is our last one, right? for now. So we divide by 8, and we're going to get x equals 216 divided by 8. I think it goes evenly, maybe. $27. So is that our answer? Not quite. It's 27 years since 1990. So they want to know what year it is. So we take 1990 and we add 27 years to it. So it's going to be 7, 9 and 2 is 11, carry the 1, 0, carry the 2017. So that'll be our answer here. Hopefully it'll let me continue. Oh, looks like it will. 2017. Let's check our answer. It worked. Okay. Delete off this stuff. And that's the end of this quiz. I guess I should submit and end. Checked it all. We got all our points. We're in good shape. And remember, on the quizzes, you also only need to get to 70%. And they'll get bumped up to 10. But they are, since they're shorter, they're good to, especially as we're getting close to the test. Some of the test questions are taken from these particular ones. Wow, just 2 chapters took us a whole hour. Those are because it's detailed, right? So what do you want to do from here? You want to have some time to work on the practice? Do you want to continue with chapter 3?
Well, I was waiting for 4, but I need you to go over 4 if you could.
Go over 4? Anyone else want to jump to 4? Come back to 3? Or doesn't matter. Okay. Let's go to 4, since take requests. And it gets boring when you just do everything in order, right? Oops, not the homework. Where am I? Let's go home. And chapter 4, quiz. Take care. Okay, you got it. Any questions in particular, or just the whole thing? Okay. And there's only 5 questions here, so it's not too bad. Now, chapter 4, if I remember right, this is where we're using Desmos, I believe. So, Desmos.
Yeah,
What?
graphics.
Yeah, graph.
The graphic, yeah. So what they'll do is they'll give us data and then use linear regression to find the equation for the linear function. Okay. So, and on the exam, again, this is how I would suggest doing it. You can use a TI-84 calculator will do this. In fact, they have all the instructions are set up to do it that way from the text. So you're welcome to do that. I found that using Desmos.com calculator will take you directly to the graphing calculator. If you just do Desmos.com, it takes you to a page, and then you can click on the graphing calculator. What we need to put in, so we're here, we need to put this data in. So we put a plus and we ask for the table. I think that's all yeah. So then we just put in all this data. So I like to put in maybe the x's first. So I do 1, enter, 2, 3, 4, 5, 6, and not 7. And then we put in the y values, 622, 660, 684, 717, 700, and 696. I think what we'll do is we'll finish this one up, and then for chapter 3, I'll make a recording of that, post it later so that you can kind of work on it over the weekend. And then I think we'll have all our we either from class, which I've got recordings of, we will have gone through all the quizzes. Now we don't see anything, and the reason is notice our Y values are up in the 600s. So if we, let me move this thing out of the way. If we click on this little wrench thing here, we know the X's are going from 1 to 6. So let's make our X-axis go from 0 to 7, a little bit more. And then our Y-axis, let's have it go from 0 to 800. And again, I'm just making sure it's big enough to include everything. And now we see our data. It's not a straight line, but they're asking us to get a line that will fit that. So what we do is we put in here, we're going to enter an equation. We're going to say that y equals actually we'll put, I think we need y1 because that's what's up there. And instead of, remember, instead of equals, we use the tilde thing, which is on your keyboard, or, where was it? It was right in here too, wasn't it? I thought,
What is it,
the little squiggly, it's up by the
You
escape.
press ABC.
Thank you.
And then it's
Okay,
right there.
and then it's this thing. Okay, I knew we had it somewhere. Thank you. So you can get it from this keyboard, or you can get it off of your keyboard. And then we have a MX, and it's got to be X1 because that's taking the data we have, plus B. And then, so what it's done is it's drawn what we call the line of best fit. Notice it goes through, it kind of averages out those, and this is what they're asking for. It's the regression. What you want is y equals mx plus b. You want the m, which is 14.94. B is 627.53. Okay, so,
Your M would be the answer.
and well, the answer, they want the whole equation, so they say y equals, so we're going to put in, let's see how many decimal places, 2 decimal places. So we're going to put in 14.49x plus, where's my other? Plus 627.53. We'll check our answer. Didn't like it. Did I not pay attention again? Decimals. 14.94. So I told you I transpose a lot, don't I? I did 49. Notice that 14.49 is 14.94. And it's 627.53. That part's okay, but I transposed the 4 and the 9. So yeah, be careful. You probably don't have to be as careful as I am, but because I just, so let's see. Now it likes it. Sometimes you can copy and paste too. I find that that helps me because again, you saw me, I make these copy errors on a regular basis. It gets frustrating, but that's why we have these extra tries and stuff. Does that help? Okay, and you'll see the next one. Again, it's really going to be the same type of thing. You'll use Desmos to come up with this equation. And then you'll be able to use those equations to come up with answers. So it's kind of a combination of what we did in Chapter 2 and some of what we do in Chapter 3 as well, but it's all about using Desmos.
It's the same equation, right?
Well, no, this one would be a different equation because you've got different data here.
I have it already. I think it's in the chapter.
Yeah. Yeah, but see, and then once you've got Desmos set up, let's come back here. You can leave this alone. You could just come in here and change the data inside here. So then just put in the new data, you get your new equation, and you're all good. So thank you guys for coming in. Again, study over it. Remember Tuesday or Thursday, whichever's your preference. Work on that practice test and you'll be all ready. Thank you, folks.
So either day we can do the midterm?
Yes.
Okay.
Your, whatever works best for you as far as your readiness. Because I had the whole week scheduled for a project, since if we're not gonna do it on one day, we can't, it's really not a one-day project. So, because of my illness, we'll just get rid of that project and we'll have an extra week to study for the exam.
So like, if I like didn't pass it on Tuesday, but I came on Tuesday,
We could do that too.
can I come back on Tuesday?
Sure, sure.
I'm so nervous.
Yeah, we'll do that. You can use your notes as well. I don't know if you, so any notes you've been taking?
My, like, what I'm nervous about, it takes me so long to do the homework, so finishing the final in one day, I don't know if I'll be able to finish it. That's, cause it takes me a while to work it out, so I don't know.
You too. Well, if you can, this weekend, maybe work through the practice test, and if you keep your notes, what you'll see is the test is actually taken from those same questions.
Okay.
So you might actually find the same one. Now, the numbers might be different, but since you've got notes on how you worked it out, it might help speed things up at that.
Okay.
And if it gets to be, if it needs 2 days, the other thing, yeah, you could come Tuesday. If you don't get it all done, they'll say freeze it in place. We'll figure it out.
Okay.
Thank you. Have a good weekend.
So for this question too, how do we do this one?
Same sort of deal. So what you're gonna do is in Desmos,
So we just put the numbers in again, like?
yeah, so you know, you can come and delete these out. Well, actually, it goes, yeah, 1 through 19. It's got different numbers here. So you're gonna, you could also clear it. You could start with a blank table, but then oftentimes it changes X1 and X2. So I just come and
Yeah, I'm just taking the numbers.
take them out, or you can type over the top of them too. So you know, but if I start with a blank, it's usually better. So yeah, it was.
Thank you.
Thank you.
Yeah, and then the equation's gonna be different, right, you said?
Well, yeah, because it's got different data. And notice this is like 11,305, and 1, 3, 7, 12, 14, and 19. 14, 19. And then it's a matter of getting this stuff in. And it really is, I mean, you have to get exactly right, otherwise you might be off by, you know, a decimal and gets marked 66.8. Some people say, do I have to put them all in? I said, well, yeah, because it's all the data. That's what it's using, all the data. 13,970. And then the last one, 14 to 45.25. But once we've done that, and it's nice if you, this equation now is going to take all that, and notice our equation has already changed. Our slope's different, our y-intercept's different. We don't see our dots because we're now up at, what, 14,000. So we could come here and not zoom, we'll,
Yeah, if you scroll out, you can see your dots.
Yeah, so we go out, so what, we need to be up around, say, let's go to 20,000. That's 2,000, 20,000. Now we see them. We can see the line. Also, the X's are going, so maybe from 0 to 20, because it goes out to 19. So now we see the data, and you could zoom out a little bit more. There it is. But you've got your equation, and so it's going to be y equals 185.286x plus the b. So it just gives you your format, and then
The investment would be M.
the investment would be, well, the M is the rate it's changing at. Based on this regression model, the value of this investment was blank in the year 1994. 1994 is the starting year. So actually B is what that's your initial value. So 11,187.8. And mine just, let's see if I lost it. Let's see, resume. And then based on the regression model, the value of this investment it's either increasing or decreasing. So that's what you use. The M is telling you whether it's going up or down. And then what the rate per year. So M goes in here.
And then rapidly there's hundreds.
And then question 4 is a similar type thing. In fact, the data looks, that's a little different, but and this one they actually want the equation. And actually, they want exponential regression. And exponential regression. And actually, what I'll do is since I said I'll do a video for the quiz 3. I'll finish these off, especially with the exponential ones. I'll do videos for those, so you can work through those. And then that way I think it was actually, maybe I didn't start until chapter 5 where we started working on the quizzes. So in chapter 5 and chapter 6, those quizzes are in the recorded lectures.
So for question 3, it says which R value implies a stronger linear relationship. What do they mean by that? Yeah, that's the one. Well, how would you know?
So that was part of it's in the lecture. So notice on Desmos, they're giving us this R value here.
Yeah.
And so R is going to be either +1 or -1, would mean that all the dots were on the line.
So
the closer is to 1 or -1.
So if it's linear, would it be positive then?
Well, it could be positive or negative.
Okay.
Positive just means it's increasing. Negative means it would be decreasing. But what we're looking is which one of these numbers is the closest, closest to either 1 or -1.
So it would be, so for mine, well, let's say for yours it'd be -0.8, and then it'd be what? It'd just be that one?
That would be it.
That
That's
would be it,
yeah.
okay.
That's the stronger linear relationship. And let's just select one.
So maybe, okay, yeah, it was the same for me, I only had one.
Yeah.
Alright, cool. Alright, so I got that. Alright, and then 4 and 5 are just pretty much the same thing.
They are, but they also want you to do exponential rather than exponential and linear. Some of these. So exponential, the equation we use is not y equals mx plus b. The equation we use is we could do this y1. We use the tilde again, and it's a times b raised to the x power. So that's the exponential one. And then when you're doing the exponential, you have to have this log mode checked to get the correct answer.
X above, oh wait, I got it.
Shift 6, yeah, that'll do it. And then you can see we've got now this exponential is getting fitted to the data.
So what, do we have to take the other, equation off for it to work, or does it not?
No,
Okay.
it can do them both. If you want, like I can, if I click on this color, it's not graphing it, so maybe it's not interfering as much. So you can sort of turn them on and off here. But or you could have them both showing at the same time. They're just both referring to the same data. And I think number 5, it has you do, let's see, number 4, based on this regression model. No, 5 might have you do both. Yeah, 5 wants you to do both exponential and a linear, so you're going to have them both on there anyway. And what I say is, if you do this in Desmos, you can use your Google account to set up an account. You save it. So on the test, you just pull it up, and all you have to do is fill in the data. You don't have to put in those equations again.
Oh, all right, I'm definitely doing that. All right. And then you just plug in the numbers, same as you plug in the numbers.
Right.
Before, all right.
And it'll give you the equation. Yeah. And then we use that R value to say which one fits best, like in the one I've got here. I've got the linears has an R value of 0.963, where the exponential is a 0.960. So I would say, the linear fits better because it's closer to 1. You know, that's.
Okay, so now that I have for 4, that I have everything plugged in, so like, when it asks for P, that will be asking for
That's Y.
the Y, okay.
Yeah.
So that would just be the equation, or, okay, let me get the equation.
So yeah, we've got Y equals, or yeah.
But
So
B
you're
is
gonna
B is
put.
the Y, right?
What's
Or
that?
Would B be the Y, or A be the Y?
No.
Because
P equals A
okay.
times B raised to the X. Or in this case, for number 4, they might want to have you use T. Oh, they want N. So they tell you what variables they want you to use. Yeah, so they're using N and P. Desmos only uses X and Y.
So how do we get the percentage increase?
So that comes from B.
Okay, so that.
So subtract 1 from B, and then multiply by 100. That gives you your percent increase. Because your B should be just like 1 point something.
Yeah. So for the C one, how would we get that number?
So you take your equation and you plug in, on mine it says n equals 8, whatever they give you. You plug that in for the exponent, and the output will be the number of people. So just take the equation you got up above.